Alright, so last type of lipid we're going to talk about here. So we are going to talk about steroids now. So I've warned you quite a few times that these do not look like other lipids, and I try to give you an early heads up on that. So what do they look like? So let's describe it first, because who doesn't love a description? Good old description, right? We got multiple ring structures. Right off the bat, you're like, rings? I don't remember any rings. Structures. Thinking of rings, trying to write structures. And so it has 3 6-member rings. And 1 5-member ring. And so you put this all together and you get what's called a steran backbone. And so this is kind of the backbone of all different types of steroids. And so they are used for intracellular signaling. So this is something that's not on the level of needing your nervous system. It's not like, oh, your hand is burning. It's more of like a, oh, you're pregnant or whatever, or oh, like you just hit puberty. So that's all done with hormones. So that is intracellular signaling, and not all hormones are of the steroid variety. I could put an extra L in there, but whatever. Who spell checks anymore? So intracellular, scribble that out, signaling. And so what does the steran backbone look like? Well, so here is what's at the heart of all the steroids. Okay, so these are our 3 6-member rings. Okay, so this is just our generic, this is like our blank canvas. This is our generic backbone, which is called a steran. There's another type of backbone as well called an oleonan. We're not going to talk about that. And also, how do you go from a straight chain with a carboxylic acid to this? You might be wondering. And the answer is a series of chemical reactions that are covered in an entire chapter of a biochemistry textbook. So we're not going to worry about how we go straight chain, boom, series of rings. Just know, you see something that looks like this with other stuff coming off of it, you got yourself a lipid. Alright, and so we'll give 2 examples here, very specific ones, just so you can see what they look like. So our first case, we're going to start out with a steran backbone. Okay, so I'm going to just draw my 6-member rings. Okay, looking good. And I'm going to get a double bonded oxygen over here. I'm going to get a methyl group there, so 1 carbon. We're going to bring in a double bond there. And what else we got? Oh, yeah, methyl group there. And off of this guy, with a double bonded oxygen. I ran out of room there, so there's a double bond. That looks terrible. All right. Oh, boy, I didn't make it better. Let's see, can I go... 2 carbons, double bonded oxygen. That's the best I can do. So there's 2 carbons, double bonded oxygen. Alright, so that's one. Let me draw the other, and then we'll talk about the names and what they do. So let's see, my next one. Guess what I'm going to draw first? Steran backbone. I wasn't kidding. This is at the heart of all of these. If you ever watch the movie The Wrestler, they show him like buy steroids and use them in that movie. It's from 2008. Classic movie. Now you know. You're like, I know the backbone of that stuff that he's buying off that bodybuilder. Who, fun fact, the guy who played the guy selling him steroids, I found out in real life, got caught selling steroids. So he really embraced the role. That's method acting at its finest right there. And if you don't know what I'm talking about, you can watch the movie and then you'll understand that everything I said was amazing and life-changing. Alright, we got a methyl group, double bonded O. We got another methyl group up here, and an alcohol. Man, I should have drawn this one on top. This one's way easier to draw. Okay, so what are we looking at here? Well, they are very similar, right? These are very, very similar compounds. In fact, the only thing that's different is right here at the top of that 5-member ring. So, this is testosterone. Literally, you'll put some hair on your chest. They have disclaimers on, you know, if you get like testosterone replacement cream, it's like, keep these away from the ladies in the house, otherwise they'll have mustaches. Pretty sure it's exactly what the bottle says. And this is progesterone. This is the, congratulations, you're pregnant. Get ready, you know. Let's make those bones flexible, because you're gonna have to like deal with an entire person shooting out of you, like kind of like the movie Aliens, but not the chest. So that's why, you know, when people are pregnant, they can't really, like, you're not supposed to lift heavy things. It's because all of your tendons and ligaments get soft, and this is part of what tells your body to do that. So it's like, get prepared, and among other things. And so I believe the first birth control was actually based on progesterone. It was just giving women progesterone pills, and it worked. It would prevent pregnancy, because, like, why would you go through the process of ovulating if you're already pregnant? That's a, that's a waste. You got a whole, you got a whole bunch of other stuff to deal with. And so, finding the right, if you dose it too high, then they might, then you start going through all the, I imagine you start getting morning sickness and stuff. I don't know if it's true, but so they had to find the right dosage. I am not a physician, just to be clear. Whereas testosterone, well, you can just take as much as you want, and there's no side effects. That's why no professional sports league tests on it. All you do is build a bunch of muscle with no consequences. That's all that is. Also, it gives women mustaches and chest hair and whatever. Makes them really angry and aggressive. Makes everyone angry and aggressive, let me be clear. But yeah, no, seriously, the tubes, I believe, do say, like, and if anyone's like, if there's like a chance anyone's going to be pregnant, it's like, don't even use it in the room with them. Like, you got to have like your special testosterone closet, like in the attic or something. You can't have any risk of, like, if someone thinks it's toothpaste or something like that, it's like, whoa, that child, you're giving birth to like a 20-pound Hulk Hogan baby or something. I don't know. But very different processes in the body, but it's a very subtle change chemically. That's really what I wanted to point out. So I draw these two compounds, and they're so similar. And then I turn around and I label them. And some of you, if you already kind of know your way around hormones and stuff, these are very, very, very different purposes, very different effects on the body. But it's such a small change chemically. That's what I really like to point out here. And how do you know these are lipids? You just look for the steroid backbone. It doesn't look like any other type of lipid you'd have seen before, but you see that boom, 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 boom. And probably the easiest one to confuse this with might be like a nucleic acid base or something like that. But there's no nitrogens. So just remember, you gotta have nitrogens for nucleic acids. You don't have any nitrogens here. So this is the one with rings. There's no nitrogens. There's no, this isn't a carbohydrate because there's not nearly enough oxygens, just to kind of help you tell them apart. And so yeah, this is kind of a tricky one. So just remember that backbone structure and just keep an eye out for it. And there's other, these aren't the only two, by the way. So there are other hormones based off of a steroid backbone, but these two were just the ones I decided to show because they have such hilarious differences in what they're supposed to do. Alright, so that does it for this section. So next we are going to talk about concentration. So sharpen up your calculator because there is math coming back in our next section. So just a heads up on that. But as always, as you're wrapping through this stuff, if you have any questions, I think lipids is probably the, I don't want to jinx it, I don't want to make anyone feel bad, but I think it's, and most of you will probably agree with me, the simplest class of biomolecule. But maybe I'm mistaken. Maybe something else is easier. But I think it's a nice one to close with. It's a nice soft close. And then boom, math gets you. Math in the next section. So like I said, your sig figs, that kind of stuff, that's coming back. Plus some new details. But ultimately the concentration stuff, there's some chemistry in there, and there's sort of kind of some applied unit conversion stuff. So nothing too crazy, and I'll walk you through it, so don't panic. But yeah, if you do have questions about lipids, you know what to do at this point. The class is well on its way, so just ask for help. That's what I'm here for, and there's a good chance if you use the forums, your classmates will just fire up an answer before I even get to it. So if you want a really fast response, it doesn't hurt. Plus, I like seeing you guys have discussions, so feel free to try that.